November 12, 1943, Koblenz, Germany. Rain drizzles against the windows of a small stone building on the edge of an army testing ground. Inside, the faint hum of machinery mixes with the smell of grease and cordite. 3 engineers from the Heereswaffenamt, the German Army Ordnance Office, huddle around a long wooden workbench, illuminated by a single hanging lamp. Laid out before them is an American rifle, captured by the 16th Panzer Division during the fighting near Salerno. Its metal gleams faintly in the yellow light. Every part has been separated and arranged in careful rows across a sheet of linen. Receiver, bolt, gas piston, operating rod, trigger assembly. Nothing appears handmade. Every piece is perfectly finished, smooth to the touch, and marked with crisp U.S. Ordnance stamps. One engineer runs a caliper along the bolt lugs and murmurs, astonished. Another examines the gas system, realizing how efficiently it channels recoil to reload automatically. The third remains silent, watching the weapon's parts come together again, clean, balanced, and without the slightest adjustment. They know this rifle, the U.S. rifle, caliber .30, M1 Garand. But now, holding it, they understand its meaning. This wasn't the work of a single gunsmith. It was the creation of an industrial giant. To understand why the M1 Garand left such an impression on German engineers, we have to return to a different time, to the quiet years between 2 world wars. After the First World War, the U.S. Army had been left with millions of bolt-action Springfield 1903 rifles. They were reliable, accurate, and familiar. But military thinkers who had seen the carnage of 1918 knew that the next war would demand something faster. The battlefield was changing. Mobility, mechanization, and firepower would define the soldier of the future. In 1919, the U.S. Army Ordnance Department began experimenting with the idea of a self-loading rifle. Dozens of inventors and engineers offered prototypes, but none could combine reliability, durability, and simplicity at the same time. Then, in 1924, a quiet Canadian-born machinist working at the Springfield Armory began refining a design that would eventually reshape infantry warfare. His name was John Cantius Garand. Garand was meticulous, soft-spoken, and tireless. Over the next decade, he worked through failures, redesigns, and endless tests. His goal wasn't to build the most complex rifle, but the most practical one. By 1936, after years of trials, the U.S. Army officially adopted his design as the U.S. Rifle Caliber .30, M1. It was the first semi-automatic rifle to be issued as the standard infantry weapon of any major power. At its core, the M1 was a mechanical masterpiece of balance and logic. Its gas-operated system tapped a portion of propellant gases to cycle the action, ejecting the spent cartridge and loading a new one, all in less than a second. The rifle fired from an 8-round en-bloc clip, which automatically ejected with a metallic ping when empty. A trained soldier could fire 16 accurate rounds in 10 seconds, compared to just 5 or 6 from a bolt-action rifle. But what made the M1 Garand truly revolutionary wasn't only its design, it was its production. Philosophy. At Springfield Armory and later at Winchester Repeating Arms, the rifle became the centerpiece of a massive industrial effort. Every part, from the smallest pin to the barrel itself, was standardized to microscopic tolerances. Garand worked closely with engineers to ensure that any part could fit any rifle, regardless of which factory produced it. This approach went beyond traditional gunsmithing. It was the embodiment of American mass production, honed by decades of automotive and industrial progress. By the early 1940s, assembly lines were turning out thousands of Garands each week, each one interchangeable, reliable, and battle-ready. While most of Europe still viewed infantry rifles as the domain of skilled craftsmen, the United States had redefined the concept. They built rifles like they built cars, fast, precise, and in enormous numbers. When war returned in 1939, the M1 Garand stood as a quiet advantage. Its effect would not be truly understood until American forces began arriving in strength across North Africa, Sicily, and the Pacific, and that's when the Axis armies, used to bolt-action rifles, started to notice the difference. The Germans called it the Selbstladegewehr amerikanischen Typs, the self-loading rifle of the Americans. Soldiers who faced it for the first time in Tunisia reported that U.S. infantry could maintain constant, rolling fire without pause for reloading. For German officers, this was not only surprising, it was deeply unsettling, because every time they captured one, they realized it wasn't handmade. It was identical to the last. By 1940, German engineers had already examined dozens of foreign weapons, French, Czech, and Soviet designs among them. Most were competent but conventional. The Americans, however, were different. Their rifles looked less like products of an armory and more like the result of a factory that thought in machines, gauges, and repeatable perfection. Germany's own small arms philosophy had grown from a very different tradition. The Karabiner 98K, the standard rifle of the Wehrmacht, was a masterpiece of pre-war craftsmanship. Each rifle was precisely fitted, with blued steel and oiled walnut. It was accurate and rugged, built by skilled hands in plants like Mauser Oberndorf and Gustloff Werke. Yet every K98K required time, patience, and specialized labor, a process that limited how quickly the army could equip millions of men. The German approach prized precision through craftsmanship. The American approach prized precision through standardization. Both aimed for perfection, but only one could achieve it at scale. When the U.S. entered the war in December 1941, production of the M1 Garand surged. Springfield Armory alone produced over 3 million rifles by the war's end, with Winchester adding another 500,000. Each one came from assembly lines designed for efficiency, operated by workers who had never built a firearm before the war began. To the Germans, this was nearly incomprehensible. By 1942, the first Garands reached European battlefields through British and Free French units supplied under Lend-Lease. Reports from the front began circulating within the Wehrmacht's Ordnance Branch. American units were consistently outshooting Axis infantry in sustained engagements. A squad of U.S. soldiers could maintain suppressive fire, normally requiring a machine gun team. At first, German officers dismissed it as Allied propaganda. But then came the North African campaign. In Tunisia, the Afrika Korps faced the U.S. II Corps at Kasserine and El Guetter. German field reports noted the unusually high volume of semi-automatic rifle fire. Rommel's staff officers wrote that American riflemen seemed to fire endlessly, forcing German troops to keep their heads down even during short firefights. The accuracy wasn't always superior, but the tempo of combat was. The difference wasn't just technological, it was industrial and cultural. While Germany struggled with material shortages, decentralized production, and bombing raids that crippled its factories, the United States had something Germany no longer possessed: uninterrupted industrial depth. The same assembly lines that built Fords and Chevrolets were now building Garands and Jeeps. Machine tools were standardized, and materials arrived on time by rail, ship, or convoy. This level of consistency fascinated the Germans who captured and studied American weapons. The M1 Garand, with its gas-operated mechanism and uniform machining, became a symbol of American capability. It wasn't just that the rifle worked. It was that it could be built millions of times over, each one identical to the next. By contrast, the German Ordnance Office was bogged down with over-complex projects. The FG-42 for paratroopers, the G-41 with its unreliable gas trap, and the MP-43, the early form of the Sturmgewehr 44, still fighting for approval amid bureaucratic disputes. The Americans had already solved the fundamental problem: How to give every soldier automatic-like firepower without compromising reliability or production. Captured M1s began appearing in German testing centers by 1943. At Koblenz, Hillersleben, and Kummersdorf, engineers studied them meticulously. Their reports noted the weapon's clever simplicity and the brilliance of its machining. But more than once, the same phrase appeared in post-war documents. Die Leistung liegt nicht in der Waffe, sondern in der Industrie dahinter. The achievement lies not in the weapon, but in the industry behind it. That realization carried a quiet dread. The rifle was only one piece of a vast system, a system that could arm, supply, and replace faster than Germany could even repair. And soon, those rifles would be carried across Europe by men who knew exactly how to use them. To the German engineers studying the M1 Garand, its true genius was not hidden in complexity, but in its simplicity. Every part of the rifle reflected a philosophy that was both mechanical and cultural. A belief that engineering should serve the soldier, not burden him. The core of the design was its gas-operated rotating bolt system. When a round was fired, a small portion of expanding gas was diverted through a port near the muzzle into a long, slender operating rod. That gas pushed the rod rearward, unlocking the bolt, ejecting the spent casing, and chambering a new round. It was an elegant cycle of controlled energy, reliable in mud, sand, or snow. Unlike many semi-automatic experiments of the 1930s, the Garand system was self-regulating. It didn't rely on fragile springs or complicated piston assemblies. German test reports from Hillersleben noted that it functioned smoothly even when heavily fouled, and that its gas cylinder could withstand thousands of rounds without damage. To men accustomed to the tight tolerances of the Mauser, this was astonishing. Then there was the en-bloc clip, an idea that confused and impressed German evaluators in equal measure. 8 rounds of .30-06 ammunition were locked into a metal clip, inserted directly into the rifle's internal magazine. When the last round was fired, the empty clip was ejected automatically with a sharp metallic ping. The system was fast, intuitive, and nearly impossible to jam. In 1943, a captured M1 was tested alongside the Gewehr 41W, Germany's own semi-automatic rifle. The comparison was humbling. The G41, designed under the constraint that no gas ports could be drilled into the barrel, an early ideological requirement from the Ordnance Department, relied on a complex gas trap system near the muzzle. It fouled easily, overheated quickly, and required meticulous cleaning. The Garand, by contrast, worked effortlessly. It didn't need to be pampered. The report that followed was frank. The American rifle shows superiority in practical function and endurance. Metallurgical analysis revealed another surprise. The Garand's receiver steel was of excellent quality, uniform, heat-treated, and stress-relieved, yet produced in massive numbers. The Germans recognized the consistency, but couldn't replicate it easily. Their steelworks were strained by shortages of alloying elements like nickel and chromium, diverted to tanks and aircraft. Even the machining marks told a story. Each Garand part showed clean, repeatable milling patterns. The surfaces were not polished by hand. They were finished by machines calibrated to exact standards. This was unheard of in German small arms manufacture, where each rifle still passed through the hands of experienced craftsmen who adjusted and fitted components individually. To the Americans, interchangeability was power. To the Germans, it was nearly an art they had yet to master. One of the engineers at Kummersdorf noted in a report, "Every part fits every other rifle. This cannot be by chance." He was right. It was by design. By an industrial culture that valued function over finesse, output over ornament. When the Wehrmacht captured enough M1 rifles to test systematically, they found another uncomfortable truth. Even when neglected, dirty, or exposed to the elements, the Garand continued to function. It tolerated battlefield abuse that would cripple many of their own weapons. In short, it was a soldier's rifle, rugged, intuitive, and forgiving. The Germans, for all their engineering brilliance, could only admire it. And behind that admiration lay an unspoken fear that America's factories could outbuild their genius. Because this wasn't just engineering, it was industrial warfare at the mechanical level. Soldiers remember how a rifle changes a fight. For American infantrymen, the M1 Garand did exactly that. It altered the tempo of engagement, the way squads approached cover, and the confidence with which a platoon advanced. The Garand did not turn every private into a marksman, but it allowed every private to sustain fire in a way bolt actions simply could not. By late 1942, U.S. units in North Africa carried Garands into contact for the first time in quantity. During Operation Torch and the Tunisian campaign, American squads learned to pair the Garand with the Browning automatic rifle and light machine guns. The M1's semi-automatic rate of fire filled the gap between single-shot rifles and crew-served weapons. Where a German squad might pause to cycle bolts, an American squad could deliver continuous aimed volleys from multiple positions, forcing the enemy to withdraw or stay suppressed. The effect was tactical as much as technological. Assault formations changed. Fire and move drills became more effective because individual riflemen could lay down accurate covering fire, while teammates advanced. At Salerno and later Sicily, platoon leaders reported that Garand-equipped riflemen could hold sectors with fewer manpower losses, since they could repulse probes without waiting for support weapons. Across hedgerows and broken towns, those extra rounds between pauses were decisive. German infantry noted the change in tone of battle. Field reports recorded stunned observations. American riflemen maintained uninterrupted fire, and firing lines could be reconstituted faster after a burst of enemy artillery. The tempo favored the attacker when it was backed by logistics, fresh ammunition, steady replacements, effective medical evacuation. Where the Wehrmacht relied on short, brutal firefights supplemented by machine guns and mortars, U.S. squads increasingly used sustained semi-automatic fire to shape the battlefield before committing riflemen to close action. There was also a psychological dimension. Seeing an opponent deliver steady, accurate fire from a rifle erased assumptions about who could hold ground. German NCOs wrote later that American riflemen often seemed to continue firing as if the rifle were an extension of their will. That perception reduced German initiative in small unit engagements. Commanders hesitated to counterattack in the open when American rifle fire could be brought to bear instantly from concealed positions. The human stories show practical consequences. Medics and quartermasters logged fewer reloading delays in after-action reports. Soldiers who survived multiple engagements described the Garand's reliability under stress, mud, rain, or snow, and how that reliability translated to fewer stoppages and fewer frantic moments at crucial seconds. Supply officers, meanwhile, learned to value interchangeability. Magazines, springs, and barrels could be swapped in the field with confidence, reducing downtime and keeping squads combat effective. Tactically, the Garand did not eliminate the need for discipline or combined arms thinking. It amplified them. Coordinated fire plans, timely artillery, and armored support remained essential. But the Garand reshaped small unit doctrine by giving every rifleman a higher baseline of sustained firepower. That new baseline forced German officers to rethink defensive postures and troop dispersal. It contributed to a gradual erosion of the old advantage held by defenders armed, primarily with bolt-action rifles. Those tactical shifts reached a new intensity in 1944 as American formations increased in size and frequency of operations. German ordnance and command staffs recognized that the rifle itself was only part of a broader system. Doctrine, training, logistics, and uninterrupted industrial output. Their study of the weapon's mechanics now turned into urgency. an insistence on answers, adjustments, and a search for a counter that could restore battlefield balance. July 1944, Kummersdorf Proving Grounds, Germany. In a long, low testing hall south of Berlin, two M1 Garand rifles sit on a steel bench surrounded by trays of spent brass. The atmosphere is methodical, almost reverent. These are among the few captured intact since the landings in Normandy, shipped to the Heereswaffenamt for evaluation. On that humid summer morning, technicians record every detail: muzzle velocity, rate of fire, parts wear after thousands of rounds. At first glance, nothing appears unusual. Then the rifles keep firing. No malfunctions, no stuck casings, no broken springs, just a rhythmic, unbroken cycle of mechanical motion. When the tests end, the chief engineer, an older man with wire spectacles and grease-stained hands, steps forward. He inspects the rifles closely. The surfaces show heat discoloration, but no warping. He looks up, silent for a moment, and finally says, "Diese Waffe ist nicht handwerklich gebaut." This weapon is not built by hand. That sentence captures what all of them have begun to understand. They disassemble the rifles again and begin measuring. Tolerances between parts vary by mere hundredths of a millimeter. The same dimensions appear again and again. Each piece fits its counterpart like a puzzle made by machines, not men. They note the gas system's brilliance: simple, rugged, and immune to fouling. The op-rod piston is self-cleaning. The chamber tolerance is broad enough to function under battlefield grit, yet tight enough for accuracy. German notes describe the construction as optimally balanced between precision and practicality. Comparative trials begin immediately. The Garand is fired alongside the Gewehr 43, Germany's latest semi-automatic rifle, developed in haste after earlier failures. On paper, the G43 matches the M1's performance. In practice, it jams after prolonged fire, its stamped receiver warping under stress. The American's rifle, heavier but sturdier, runs flawlessly. The Germans' frustration deepens with each test. They are not witnessing superior design alone. They are witnessing a different industrial philosophy. The M1's parts are all milled with uniform precision, a feat achievable only by massive, standardized production. The Americans have built machine tools for their machine tools, layers of production engineering that ensure consistency even in wartime. At one point, a technician holds up a bolt assembly and says quietly, "We cannot copy this, not as it is." He isn't referring to the blueprint. They can reproduce that easily. He's referring to the system behind it. The coordinated factories, the automated gauges, the conveyor-driven assembly lines that make perfection routine. Reports compiled that summer describe the M1 as a symbol of the enemy's industrial organization. One internal memo admits that no German factory could match its output without abandoning current methods. Another warns that if the Americans can mass-produce rifles of this quality, their tanks, aircraft, and artillery must follow the same logic. By autumn 1944, these findings circulate through the Ordnance Department. Among the engineers, the verdict is unanimous. They have no equivalent. The Garand is not unbeatable as a weapon, but it represents a kind of strength Germany can no longer reach. The engineers have done their job, but the truth they've uncovered carries a weight heavier than any rifle. Because now, every man in that room knows. This is what industrial defeat looks like. Precision at scale, repeated endlessly across an ocean. August 1944, Oberndorf am Neckar, Germany, inside the Mauser-Werke complex. The sound of stamping presses and lathes fills the air. Workers in oil-stained overalls assemble rifles under the pressure of endless air raids and shortages. Aluminum is scarce. Steel quality is inconsistent. Power outages are common. Yet on one workbench, a single M1 Garand sits disassembled. surrounded by German engineers studying it like a relic from another civilization. Each man knows Mauser's legacy. The company built the Gewehr 98, one of the finest bolt-action rifles ever made. But this American semi-automatic rifle has changed the conversation entirely. One engineer points to the Garand's receiver. It's milled cleanly, with no visible tool chatter. Even the underside, a place no soldier would ever see, is perfectly machined. Another points out the stamped trigger guard. Mass-produced, yes, but fitted with absolute precision. They've reached a point where a factory can make thousands of these, he mutters, and everyone will perform the same. A younger assistant brings over a G43 receiver from the next table. It looks rougher. Tool marks run across the surface. Fitment requires filing. Its gas system, copied from the Soviet SVT-40, is fragile and prone to carbon buildup. The comparison is painful to watch. Documents from the time reveal their growing admiration. The Garand's entire assembly process was modular. Springfield Armory, Winchester, and smaller subcontractors all produced parts that could be swapped interchangeably. The Germans note this with astonishment. Their own factories, bound by older methods and inconsistent measurements, can't achieve that level of standardization. What shocks them even more is the American philosophy behind it. The U.S. Army never designed the M1 to be perfect. They designed it to be repeatable. It could be made by thousands of workers, many unskilled, across hundreds of facilities, and still function in mud, snow, and sand. In contrast, the German model of production still glorified craftsmanship. Each rifle was, in a sense, a hand-tuned instrument. But in 1944, that pride in precision had become a weakness. Skilled labor was vanishing. Materials were dwindling. Bombs were falling. One engineer writes in his report, "The American design philosophy represents the true weapon. Not the rifle itself, but the method of its creation." They realized that even if Germany captured the Garand's blueprints, it wouldn't matter. Without the industrial ecosystem, the interchangeable tooling, the supply chain, the inspection systems, those blueprints would remain theoretical. That revelation spreads far beyond the rifle. The engineers begin comparing notes from other captured American weapons, Browning machine guns, bazookas, and even tank components. Each displays the same trait: reliable function through mass precision. By late August, internal communications describe an uneasy respect for American industry. One classified report concludes that the strength of the United States lies not in the superiority of design, but in the discipline of its machines. Meanwhile, on the front lines, German infantrymen discover this truth firsthand. In Normandy and the Hurtgen Forest, they encounter American squads firing rapid, accurate volleys from their M1s. A sustained rhythm no bolt action could match. Many German soldiers mistakenly believe the Americans are armed with automatic rifles. The volume of fire feels inhuman. Back in Oberndorf, the engineers read those combat reports and understand what they mean. Their technical analysis is no longer abstract. The factory lights flicker as an air raid siren begins to wail in the distance. Someone covers the Garand with a rag before running to the shelter. For a moment, the rifle sits alone on the table. The product of a nation that had mastered not just warfare, but the machinery of progress itself. The engineers would later call it Die amerikanische Waffe der Zukunft, the American weapon of the future. And as Germany's factories burned, that future was already closing in. May 1945, Nuremberg, Germany. The war was over. The German Reich had collapsed into ruins. Across Europe, Allied soldiers now walked through what had once been enemy territory, their M1 Garands slung casually over their shoulders, symbols not only of victory, but of an industrial philosophy that had triumphed as decisively as any army. In American depots and captured armories, teams from the U.S. Army Ordnance Department began cataloging enemy weapons for study. Rifles, machine guns, and prototypes were gathered by the thousands. Among the collection were numerous captured M1 Garands, taken from fallen Americans during the war, now retrieved and brought home again. When the engineers at Springfield Armory reviewed reports from Germany and Japan, one pattern stood out clearly. Their enemies had studied the Garand deeply and almost universally admitted that they could not match its production scale. The weapon had been analyzed by engineers at Moser, Walter, and even in occupied France. Each had tried to adapt certain elements, but none could replicate its consistency. What made the M1 unique wasn't only its semi-automatic operation or reliability in the field. It was the sheer system that supported it. The inspection standards, the gauging methods, and the national industrial discipline that ensured every part would fit perfectly. Whether it came from Massachusetts or Missouri, American reports later noted that this same principle, decentralized precision through standardized design, was the backbone of U.S. logistics. It wasn't just rifles. It was trucks, artillery, and even aircraft engines. Everything could be repaired anywhere, by anyone trained to follow procedure. For German officers and armament planners, this realization was devastating. The Wehrmacht had built extraordinary weapons, the Tiger tank, the MG-42, the V-2 rocket, but at a price. Each was complex, expensive, and difficult to produce in quantity. For every Tiger that rolled out of a German factory, the Americans produced dozens of Sherman tanks and thousands of Garands. In post-war interviews, captured German engineers spoke with a kind of reluctant admiration. One recalled, "We could not imagine a rifle made so quickly, so precisely, and by so many hands at once. It was as if the Americans had made the factory itself into a weapon." Even General George S. Patton, who had carried the Garand through much of the campaign, famously declared it the greatest battle implement ever devised. For him, it wasn't about sentiment. It was simple arithmetic. American infantrymen armed with semi-automatic rifles could deliver nearly double the volume of fire compared to German soldiers with bolt actions. In the ruined streets of Nuremberg, where American patrols still encountered scattered resistance, that advantage was clear. A single squad with M1s could dominate entire city blocks, suppressing enemy snipers with bursts of accurate, sustained fire. As the occupation began, American military advisors inspected German armories and production sites. They were shocked by the contrast. Many workshops still relied on manual fitting and finishing. There were no standardized gauges or nationwide inspection protocols. In some cases, two rifles from the same model line required entirely different bolts to function properly. What had once been a proud tradition of German craftsmanship now looked like an obstacle. The modern world demanded precision in numbers, not perfection by hand. The Garand had proved that principle on the battlefield. It didn't just win firefights. It represented the future of industrial warfare. That realization would soon shape the next generation of global armaments, both in defeated Germany and beyond. October 1946, Springfield, Massachusetts. The war had been over for more than a year, but inside the sprawling complex of the Springfield Armory, the echoes of World War II still lingered. Workbenches were covered with blueprints, calipers, and rows of Garand receivers stacked like metallic monuments to the American arsenal. Technicians were now studying enemy rifles, Mauser K98s, Gewehr 43s, and even late-war prototypes from Germany's secret factories. But there was something deeper happening here. The United States wasn't simply reviewing weapons. It was codifying an entire doctrine of how to make them. Reports from captured German engineers had poured in through Allied intelligence. The recurring message was clear. The Germans admired the Garand's function and marveled at its production. One former Mauser technician, interviewed by American ordnance officers, confessed that the Garand could only be born in a nation where machinery itself is an art. He wasn't exaggerating. By 1945, over 5.4 million M1 Garands had been produced. Every rifle, from early Springfield models to Winchester variants, met the same dimensional standards, interchangeable down to the smallest pin. In comparison, the German G43 rifle, introduced only 2 years earlier, had fewer than 450,000 units completed, many plagued by reliability problems caused by rushed machining and material shortages. The Allies saw that contrast as proof of a greater truth. In total war, manufacturing discipline could be more decisive than battlefield tactics. America had industrialized precision itself. The lessons learned from the Garand didn't end with the war. They directly influenced post-war developments like the M14 rifle, a refined descendant that carried the Garand's DNA into the Cold War era. Its gas-operated mechanism, rotating bolt, and durable receiver all stemmed from the same foundation. Meanwhile, in Europe and Asia, nations rebuilt their armories with American principles in mind. West German engineers working under Allied supervision studied American production methods closely. When the Bundeswehr later adopted the G3 rifle in the 1950s, it reflected those lessons: simpler parts, modular assembly, and mass interchangeability. Even the Soviet Union quietly acknowledged the American achievement. Their post-war semi-automatic rifles, like the SKS and the early prototypes of the AK-47, incorporated production philosophies inspired by what they had seen in U.S. weapons recovered from the battlefield. For John C. Garand himself, the man behind the rifle, the end of the war brought quiet recognition. In 1941, he had stood in his modest office at Springfield Armory, watching the first rifles roll off the production line. He had never imagined that his invention would become a global benchmark. When reporters visited him after the war, he spoke little about fame or credit. Instead, he talked about the men who used it. "It wasn't meant to be beautiful," he said softly. "It was meant to work, and it had. From Normandy to Okinawa, from Bastogne to the Rhine, the M1 Garand had not only armed a generation, it had defined one. By the late 1940s, Springfield Armory began preparing for new challenges: jet-age weapons, new materials, and changing warfare. Yet, within the walls of that historic armory, the sound of the Garand's bolt, that sharp, metallic ping, still echoed as a reminder. It was the sound of a rifle that symbolized not just American firepower, but American capability itself. The engineers who once studied it in secret German workshops had been right. The Garand wasn't just a weapon. It was a blueprint for an industrial future no other nation could yet match. The age of modern mass precision had begun. When the guns of World War II fell silent, the M1 Garand remained more than a weapon of victory. It stood as a mechanical symbol of what defined the American war effort: method, order, and the ability to turn invention into mass reality. For every nation, the war had been a test of endurance. But for the United States, it was also a demonstration of what industrial democracy could achieve. The Garand proved that excellence did not have to come from artisans or secret workshops. It could come from coordination, from thousands of workers guided by shared standards and unbroken logistics. German engineers, once proud of their fine tolerances and hand-polished chambers, left the war understanding that a new age had arrived. It was no longer the craftsman who decided the outcome of wars, but the system that enabled him. In that sense, the Garand was both a rifle and a philosophy, one that blurred the line between machine and nation. Every trigger pull on a battlefield in France or the Philippines echoed the synchronized rhythm of American factories, railways, and assembly lines half a world away. Decades later, when soldiers carried the M14 and M16 into new wars, they were still carrying the essence of the Garand: simplicity, reliability, and repeatable precision. Its design had evolved, but its message had not changed. The M1 Garand did not just help win World War II. It redefined how victory was made possible. It reminded the world that strength was not only in steel and powder, but in the human will to organize, innovate, and build, again and again, perfectly, by the millions. The rifle had fired its last rounds, but its legacy was just beginning.